What we're going to focus on today is, like if we have those transformations produced by the values of A, B, C, and D, where we get new amplitudes, new starting points, so horizontal, vertical shifts, or new periods, how can we actually graph those wave functions with those transformations? Before we get into that, we'll talk about the sine and the cosine, and I think I forgot in fourth hour to talk about the amplitude and period of the parent graph. So if you go back to your notes from Friday, I think it is a good idea for you to label amplitude and period for each of these graphs, just because that's what's normal for the parent graph, and then you can talk about how a wave has been changed, like if there's a stretch or shrink or shift up, down, left, right. So remember, amplitude was half the distance from the minimum to the maximum. The amplitude for a sine graph is what value then? 1. Half the distance from the min to the max. The min is -1, the max is +1. That's a distance of 2, so the amplitude is 1. It's really like half the distance from the midline. So amplitude would be 1. And the period was the horizontal distance that it takes the graph to do one cycle before it starts to repeat itself. So for the sine graph, we've got one whole mountain, one whole valley, and then everything else would be a repeat. Mountain, valley, mountain, valley. So this period is how far? 2 pi. We probably mentioned that in our notes on Friday, but we didn't necessarily write it down. And the same is true for cosine. The amplitude is 1 and the period is 2 pi. It's really just a different picture. So that kind of confirms some of those things, like when we were doing the period last Friday, when we do 2 pi over b. Remember, b is responsible for your horizontal stretch or shrink, so that's changing the original period. Okay. The other two things that we want to make sure we put down because once we get into graphing, we go back to those domain and range questions. So let's talk real quickly about domain and range. Remember here that this image that I have, this is just one period. I really take this graph and copy it infinitely many times. So it's a wave that's continuous in the middle, going on forever to the left and forever to the right. So domain would be all real numbers. We're going to use interval notation. So we'll say negative infinity to positive infinity. And what that means is you can really, for sine of x, you can put in any angle. You can always find the sine of an angle. Positive, negative, between 0 and 360, more than 0, or less than 0, more than 360. You'll be able to do the sine. But the range, when you're looking at range, remember range is what you can get out for y's. You're stuck in the confines of your wave, right? You've got a min and a max value. So our range is going to be from -1 to 1, our min and our max. Should we use brackets or parentheses? What do brackets mean? Included, right? Can you actually get a sine value that is -1? Yeah, if you were on the unit circle, your sine would be -1 if you were the angle 3 pi over 2. And can you get a sine value of +1? Yeah, if you're on the unit circle, you would be at the positive y-axis, so pi over 2. So we want to use brackets for range, that the mins and maxes of this wave are included. Now, on a quick side note, and we've already done those inverse trig functions, so we saw the domain and range flip, but then we restricted the range for inverse sine, so we'd all get the same answer. It makes sense that the range for a sine function is between -1 and 1, because when you think about sine in geometry, just like on a regular right triangle, it's the ratio of opposite over hypotenuse. And in a right triangle, the opposite side is always going to be one of the legs. the hypotenuse is always the longest side. So no matter which leg you have of your right triangle, if you're doing opposite over hypotenuse, you're doing small over big. Well, small over big is always less than 1. So it would make sense that sine gives outputs between -1 and 1. And the same would be true for cosine, right? Because it would be adjacent over hypotenuse, and the hypotenuse is still the longest side. So adjacent over hypotenuse would really be small over big again. Okay. And we could recognize like it will have the same domain and range because it's essentially the same shape, just a horizontal shift. Don't judge my infinities, Madison. I wasn't looking. Is that what you guys have been laughing about all morning back there? Yeah. Try to make eye contact with everybody. It's hard and right on the board. It's difficult. So they're the same domain and range. But of course, if I do stretching, vertical shifts up and down, I'm going to have some changes, possibly to my range. Will I ever really be changing my domain? Not really, unless it's like an application problem and it's how many times I went around a Ferris wheel, right? But otherwise, if it's just a random cosine, it's probably going to be all real numbers all the time. Okay, you do not have to write this next slide down. I just want to talk to you about what's going to happen with graphing. So, with graphing trig functions, we use something called the framing method. So that's over here. It's called the framing method. What I want you to be thinking about with the framing method is essentially you're going to build a frame, or I often refer to it as a window. It's this big rectangle. And within the rectangle, you're going to be splitting it up. Of course, we have the midline for our graph. So the top of the rectangle is the maximum, the bottom of the rectangle is the minimum, and we got the midline. And then we're also going to split it up into 4 sections. So we have like an 8-paned window. Now, going back just really quickly to the 2 parent graphs, notice how when we restricted it down to like the 5 critical points, we sort of are building within that frame. So I've got a big frame that would encompass all of that. And then I got the midline, which would split the frame in half vertically. And then at each of these points, I'd be cutting my frame up into these 4 equal sections. So in order to build the frame, we're going to use the 3 things from Friday. For today, sine and cosine, your starting point will always be on the middle left of your frame. So this is like your vertical axis. Okay. This will be the y coordinate for your starting point, like what's its y value, and then you can add the amplitude and subtract the amplitude, and that's like where your mins and maxes are in your wave. Down at the bottom of your frame, you'll build the spacing horizontally, which is part of the period. So I'll only ever ask you to graph 1 period of a sine cosine. The book may say like draw 2 periods, but you only need to really do 1 because to me the rest is copy paste. So you need like 1 full period, and then that period will be broken up into 4 equal parts. Now I'll give you 2 methods for how you can get those numbers down at the bottom, like what are those values. And then in this, you'll either decide, like, is it a sine graph, so mountain high, valley low, or is it a cosine graph, so I start at my maximum and go back to my maximum. So you're kind of drawing the same pictures every time. There are pros and cons to the framing method. Pro, people do a lot better within a 1 window frame than trying to figure out where it goes here on the coordinate plane. So we're going to see a lot more success, people getting correct points on their graph using the frame. Con, your graph is always stuck in this little window. They all look the same. Like every sine graph you draw kind of looks like every other sine graph you draw. even though some of them have been vertically stretched or shrunk, horizontally stretch or shrink, shifting up and down, left and right. You don't ever see it because it's just in that little window where you're like zooming in. Okay. And so you don't always see it in context of where it sits on the coordinate plane, where it would be in relation to its parent graph. That's something I'll talk about at the end of each of our examples. Like, stop for a minute and think about where this frame actually is, like where this window is compared to the rest of your graph, like your coordinate plane. So that's the one big con. But it's nice because what the points that we put here into the frame, you could always transfer onto a coordinate plane, and then you would have like a very accurate graph of that trig function. Okay, so this I have a sheet for you. Some of the pods have tape already. So if you have tape, grab a couple pieces and tape it into your notebook, and then move that tape to another pod. You need just a couple pieces, tape it in. It need not be around the entire border. See, that's like wasting my tape. Leave some tape for the other classes. And if you're not actively taping right now, read through the steps. Okay, read through steps 1 through 5. Once you get it taped in, take a minute, read through steps 1 through 5. Move that tape from pod to pod. Don't keep the tape at your pod, please. Less dramatic. I really appreciate it. There might be racing. Their pulse probably only went up about 3 beats per minute. Okay, if you're taping, that's fine. Go ahead and take the time to tape it in. But you might have noticed as you kind of skimmed over steps 1 through 5, you already know steps 1 through 3, right? Find the amplitude, find the starting point, find the period. Okay. So steps 1 through 3 is stuff you already know from Friday. So those of us who practice on the homework, we got that stuff down. Step 4 is basically the new part for today, like can you build the frame? So notice down at the bottom, your starting point is the same for all sines and cosines. It's in the middle on the left. That will change when we get to tangent. Okay, we're going to put the starting point somewhere else. Okay, but for right now, it's in the middle on the left. Okay, the amplitude, notice in number 2, that's your vertical spacing. So when you put your starting point down, you'll add the amplitude to your y-coordinate. You'll subtract the amplitude from your y, and those will be your mins and maxes. And then the period is more in detail down here. It's your horizontal spacing. So I gave you 2 methods. Method 1. Whatever your x-coordinate is for your starting point, that's the beginning of your frame on the left. Add the period to it, and that's the end of your frame. And then you have to be kind of skilled at fractions, like what's in the middle of those 2, what's in the middle, what's in the middle. So you do like a bunch of halves. If you are not feeling like you're confident that you're halving the fractions correctly or getting the middle of the fractions, then you should go to method 2. Method 2 is probably like my go-to method for anybody who feels like they're not sure how to label the horizontal axis. Then you want to star, circle, or highlight method 2. Method 2 just basically says take your period and divide it by 4. Multiply it by 1/4, divide by 4, split it into 4 equal parts. And then whatever your starting point is for x, add 1/4 of your period. That's your next spot. Add 1/4 of your period. There you're halfway. And then do it 2 more times and you'll get those values on the horizontal axis. Okay. So you really want to focus on your homework tonight. Can you do this part, like label your frame correctly? The last one would be plot the 5 critical points and sketch the graph. And this you need to make sure you do at the bottom of your blue sheet. You already know 2 of the graphs, right? Sign with the positive A is going to start at the starting point in the middle. And then we're going to go mountain high and valley low. So those are going to be our 5 critical points that we label. You also already know cosine with a positive A. It starts at the maximum. So notice the starting point for the frame is not the starting point for your graph. Your graph does not have to go through the starting point. Okay, so it starts at the maximum, ends at the maximum, minimum would be in the middle, and my 2 critical points are there at the midline, and then I can draw my cosine. All right, those are the same shapes we saw on Friday. And then, of course, if you notice that your A happens to be a negative, we talked about on Friday, that's a reflection in the horizontal axis. So for sine, that would mean my mountain would switch to be a valley, and my valley would switch to be a mountain. All of the midline points will stay the same when you do the reflection. So there's a sign with the negative A. And then for cosine with the negative A, I'm going to start and end on my minimum. And my middle value is going to be my maximum. Remember when you're drawing cosine on the edges, make sure that it's apparent that that graph is turning around right there. It should not look like a parabola, like it's going to just keep going up. It should be rounding out. And like those are really the only 4 pictures you're allowed to draw for today. So you keep drawing this rectangle in this frame and you stick those pictures in. That's like one of the cons of the framing method, is that your sine graphs will all essentially look the same. Same size, same spacing, but because of the labels, we'll know that's not actually true. Okay, you got those? Do your pod a favor and just glance over at your pod and verify that your shape and their shapes are looking about the same for those 4 bottom graphs. And tell somebody if you think they might have graphed one of them incorrectly. You think they missed a critical point. Okay, let's graph this one. Y equals 3 cosine 1/2 x. With your pods, do amplitude, period, and starting point, and I'll call on you guys here in just a minute. So I would talk with my pod so you have an answer. I'll call on whoever I want. Period, amplitude, starting point. Y equals 3 cosine 1/2 x. we ready? Any more time? You got it? All right, Lucas, what did your group say for amplitude? Sorry, what? 3. Yes. You're far away and I can hear that projector, so it's hard for me. Okay, 3 is correct. This 3 times cosine, since it's being multiplied in front, that's an A value, right? And the absolute value of 3 is 3. Remember, amplitude should always be positive. Luke, what did your group say for period?
4 pi.
4 pi. Can you tell us how your group got 4 pi?
Yeah, it's either 2 pi or 1/2.
Excellent. So you're doing 2 pi over b. B is whatever's being multiplied in front of your x. Since it's 1/2 x, we know that b is 1/2. And just be really careful here. 2 pi divided by 1/2 means that you're multiplying by the reciprocal 2 over 1. So you should get 4 pi and not pi. Got to be really careful with dividing that fraction. All right, and then Grace, what did your group say for a starting point? 0, 0. Notice there is no C or D being added or subtracted, so starting point is going to be a 0, 0. Okay, we got the stuff from Friday. Now we're going to build a frame. There's my window. I'm going to make my 8 panes because this is how I'll decide like where my critical points are going. And in fact, we could argue like you're ready to graph your shape right now, aren't you? It doesn't really matter because I'm not putting it on the coordinate plane. I'm just putting it within that one frame. I just have to look at the fact that this is a positive cosine graph. And I know what shape I'm going to draw in my window. I'm going to start at the max and end at the max. And then in the middle is going to be my minimum. And then at the 2 like 4th pieces, I'm going to be at my midline. So that's like considered one or 2 points on every graphing quiz or graphing problem on a test is did you draw the right function, sine or cosine, and is it reflected or not reflected? So make sure that you can pick the correct picture to put in there. Okay, so all your graphs for positive cosines are really going to look like that. The difference is going to be when you start labeling the frame, like where is this actually happening? So I would start with my starting point. We were told, Grace gave us the starting point of 0, 0. So this is my x and this is my y. And I'm going to put those like where they would go. You know, of course my starting point is right there on the left side of my frame. But I'm going to say like this is my vertical, so this is my y's, and then this way is my x's, my horizontal spacing. So I'm going to put a 0 here for y, and then down here, this is like the first line right there, that's going to be a 0 for x. So that starting point is 0, 0. Notice that the starting point 0, 0 isn't actually on this cosine graph, right? The cosine doesn't have to hit the starting point. Okay, it's the starting point for your frame. Okay, well, amplitude is really easy. That's my vertical spacing. So once I decide what my y coordinate is for my starting point, I just have to add and subtract my amplitude from that. So 0 plus 3 is 3, and 0 minus 3 is negative 3. So all the points on the minimum or on the top of my frame have a maximum y of 3, and all the points on the bottom of my frame have a y value of negative 3. And in the middle, if you're on the midline, you're 0. Okay, I'm going to talk about the 2 methods for horizontal spacing. On this one, method 1 is not bad. Okay. Method 1 would be go to your period, 4 pi, go to your x coordinate starting point, 0, and add 4 pi to that. So 0 plus 4 pi is 4 pi. So the end of my frame must be 4 pi. Okay, so that the distance from 0 to 4 pi is my period, which it would be. Then, if you're using method 1, you're just like understanding that each of these are evenly spaced. So what's right in the middle of 0 and 4 pi? 2 pi. That's half. And then what's right in the middle of 0 and 2 pi? 1 pi and 3 pi. Right? That one's really easy. So I like method 1. Okay, easy to split up 4 pi. If I were doing method 2, method 2 for my horizontal spacing, I would take my period 4 pi and I would divide it by 4 or multiply it by 1/4. Probably dividing by 4 is fine here. And isn't my spacing supposed to be 1 pi? So then I could go to this starting point at 0 and I could just say, okay, 0 plus that spacing, pi, is pi. And then once I get that number, pi plus pi is 2 pi. And 2 pi plus pi is 3 pi, and 3 pi plus pi is 4 pi, obviously, right? This one's easy, so you're like, why are you showing me both of these? Well, it gets harder when the period is 2 pi over 3. It's not as easy to cut that one in half and then cut it in half again. So if you're struggling with method 1, or if you have like horizontal shifting left and right, it's harder to figure out like what's in the middle. If you're having trouble with method 1, go back to method 2. It's like surefire. And you'll get that answer. Okay, so now I can label my 5 critical points. If you have labeled your frame correctly, this is really easy. This point up here is 0, 3. Okay, my x is 0, my y is 3. This point at the midline is pi 0. This point right here is 2 pi negative 3. Here is 3 pi 0. And then this is 4 pi 3. And the benefit of labeling these 5 critical points is that would make it much easier for us to graph on something like an actual coordinate plane. If you found out what those 5 critical points were, you could plot those points over here and get a more accurate graph, like on a not frame, just like on the coordinate plane. Anybody have any questions for me so far? Okay, you'll also be asked, so we got the graph and the 5 critical points. You'll also be asked for domain and range. So I'm going to squeeze that in down here at the bottom. Domain is easy. Even though we're only graphing one period, we understand that doesn't this graph go on? So if you want to draw more parts of the cosine, you're welcome to. That's totally fine with me. But you can also just draw one cycle. Know that the domain is all real numbers. What's your new range? Yeah, you just look at the vertical side, right? What's your low and your high? Those are going to be the endpoints of your range. So negative 3 to 3. Okay, the last thing I'm going to say before we do one more example is, every time I graph a cosine, I said this earlier, they're all pretty much going to look like this. Like I always tend to draw my frame the same size and split it up into the 8 equal parts. So like really all your cosine graphs look the same. But like if I compare this to like what the real cosine graph looks like, think about in your frame. We actually had the point 0, 0 in the frame, right? So do you agree that this starting point is like the origin for my coordinate plane? Okay, 0, 0. So I've got like my y-axis. There's my y. Here's my x-axis. And if I think back to the parent function for cosine, remember its amplitude was only 1. So in terms of this wave's amplitude was 3, so I have a shorter wave. And its period for the parent graph is only 2 pi. So I will do my whole cosine graph just in 2 pi, where this one took 4 pi. So if I'm thinking about like the comparison there, my graph of the parent function of cosine probably looks something like that. And I could get another one in there because it has, that one takes twice as long. So this is the part, like the green stuff you don't have to draw in. I just want you to be thinking about. That's the stuff you don't see in the frame. It's like, is this wave really big? Or maybe, like on your homework you had those amplitudes like 1/5. Is this wave really short? Is this wave stretched or shrunk horizontally? Those are things that you can think about in comparison to its parent function. Let's see. We're going to do one more. And I'm going to do this one, but I'm going to change it to a sign. So 3 minus sine of x plus pi x. And I'll give you some time to do amplitude, period, starting point. If you want to start building the frame, that's fine. I'm going to be spying over people's shoulders. And I'll put up what I see for periods, amplitude, and starting point. If you want to chat with your groups, that's cool. These are the 4 answers I saw around the room. Only one of them is correct. So anyone want to make an argument for that one should not be on the list or that one is the answer? I know I can nix one of them right away. Which one? 0 can't be an amplitude. You can't have a height of 0 for your wave. Then it's just a straight line, right? That's pretty boring. That's not really even a sine or a cosine. So it's not 0. Randall? And it's not -1. Why is it not -1? Amplitude isn't negative. It's the absolute value of something. And absolute value is always positive. Okay. So now it's the question of 3 or 1. Anyone want to argue for why it's one or the other? Logan?
It's not 3 if that's not being multiplied to the side.
Oh, it says 3 minus the sign. And A is supposed to be like multiplied by the sign. Okay, so if we think about that general form, isn't this A sine of bx minus c, and this guy out here must be my plus d, but it got moved to the front. Okay, so like it's a really easy, I'm glad I saw those 4 different answers around the room. It's really easy to just look right at the front and say that number, but sometimes that's D. So if you see a plus or minus behind it, that's not A, that's a D. So I would argue the correct answer for amplitude is 1. I'm going to do another round, see if you can get period and starting point for me. I'll see if we're like in agreement on this one. Another wide array for starting points. So period, I think we're in general consensus that it's 2 pi. Because we're doing 2 pi over b, which b must be 1. Okay, so I agree with that. Period is 2 pi. Here are some of the things I'm seeing for starting point. Whew, so many choices. Any were positive are not correct. Probably an easy thing to figure out, like could get rid of some of them, is D, right? Because you don't have to do anything with D other than identify it. What is D? 3, okay? Look at the front. It does have a minus in front of the sign, but that means that A is -1, and we dealt with the fact that it can't be negative, it has to be the absolute value. But this 3 is actually positive, isn't it? So D has to be up 3. So I think anybody, and there could be other ones where like there was a -3 in there. I had quite a few people have a -3, but D is positive. Okay. Any others you feel good about or you want to nix? Okay.
I think maybe 5 halves 3 is the correct answer because C is the opposite of what it seems.
Do you remember that? It's in your notes from Friday. The equation says minus C. So C looks like the opposite of what it really is, just like H did. If it said minus C and now it says plus, I must have put in a negative pi halves. So then this would be my answer, right? It would be negative pi halves over B, which is 1, but that would just be negative pi halves. These two are you did B over C instead of C over B. So you got the reciprocal. So those two are the reciprocals, and then this was the other most common one. Gotta be a negative. Okay. So I'm going to throw up my frame. This is, like, pay attention to this, like on your homework. Obviously, there's a bunch of numbers in the formula, but there's only one right answer for those 3 things to get the right graph. Don't just guess it. Like, look back in your notes and make sure you're choosing the correct value. Decide early on what A, B, C, and D are, that kind of thing. Okay, I'm going to put my starting point up. So the y coordinate of my starting point is 3, and the x coordinate of my starting point is negative pi halves. Using my amplitude of positive 1, don't I just add that to 3? So my max is at 4 and subtract that from 3, so my minimum is at 2. Which now I can answer range, right? Domain is going to be all real numbers, negative infinity to infinity. And even without the picture, I know that the range is going to be 2 to 4. It won't be negative 1 to 1 just because the amplitude is 1, because I had a vertical shift up 3. Okay, so the low point is 2 and the high point is 4. Okay. I'm going to use on this one method 2. And I'm not going to show as much work, but take my period, 2 pi, and divide it by 4. 2 pi over 4 is pi halves. So my horizontal spacing is 2 pi over 4, or pi halves. Negative pi halves plus pi halves? 0. Plus pi halves? Plus pi halves? 1 pi. Plus pi halves? 1.5 pi, or 3 pi over 2. You could have got the same answer if you just added 2 pi to negative pi halves. 2 pi plus negative pi halves is 3 pi halves. And then what's in the middle of 1 half and 3 halves? Negative 1 half and 3 halves. A positive 1 half. What's in the middle of 1 half and negative 1 half? 0. What's in the middle of 1 half and 1 and 1 and a half? 1 and a half? 1. Draw my sign, but this sign is reflected, isn't it? Then we have a negative A. So make sure you do valley low, mountain high. And then you could go through and do your points. Just really quickly, again, I just want to point out, think about where this actually is on a coordinate plane. I do have 0 for x, but I don't even have a 0 for y. So that must mean there's 2, 1, 0. This is my y-axis and this is my x-axis. So my whole graph has been moved up, right? That wave sits above the x-axis. It has no x-intercepts. And then my sine graph, my negative sine graph has been shifted left pi halves. It's not starting on the y-axis. If you looked on the y-axis, you might have called it a negative cosine graph. Your homework assignment is whatever the gold sheet says for 4.5b, which should be 4 graphing from page 306. So I want you to do the same things we did in the notes. Figure out your amplitude, starting point, period, label the frame, and label the 5 critical points, and do domain and range. Obviously, if you get the wrong starting point, like if you had started it at pi halves 3, then your horizontal axis is going to be different. We'll address that, but I always try to give partial credit, so more work you show, better chances of getting some points.